Welcome to everyone. Already we have studied the expansion of the solids and liquids due to external thermal energy. Now you will learn about the expansion of the gas. In that I will discuss about the fundamental laws of gases. Before going to learn about the fundamental laws of gases, we will understand or we should understand or realize this two-dimensional demonstration. For that, I will take a cylinder. In that cylinder, filled 1 mole of gas and closed that cylinder with a frictionless piston. After this, I will pulling up this piston. Pulling up this piston, then what will happen? The volume of this gas will be increased because of due to this pulling up of this piston, there is some extension of space in this cylinder, then this gas molecules will get expand towards the upward. Due to that, the volume of this gas will be increased, then the pressure of this gas will be decreased. Then what about temperature means? The temperature of the gas will be decreased. Piston pulling up, then volume increased. Due to this increment of volume, the pressure of this gas molecules will be decreased. Then automatically the temperature of this gas will be decreased. Why? Because the pressure of the gas molecules is directly proportional to temperature. That means the temperature of the gas molecules will be increased when pressure of the gas molecules increased. The temperature of the gas molecules decreased when the pressure of the gas molecules decreased. But the pressure of this gas is inversely proportional to volume of the gas, so that when pressure of the gas will be increased, then volume of that gas will be decreased. At the same time, pressure of the gas will be decreased means the volume of the gas will be increased. These are the important parameters and properties of these parameters when the piston of the cylinder pulling up. And one more case I want to elaborate here. In the second case also, I will take a cylinder, then fill that same quantity of gas, that is 1 mole of gas in that cylinder, then that is closed with the help of frictionless piston. Then I will pulling down this piston means automatically the volume of this gas will be decreased. Volume of the gas will be decreased means automatically the pressure of the gas will be increased. Because of volume of the gas decreased means pressure of the gas increased. Why? Because pressure is inversely proportional to volume of the gas. At the same time, when pressure of this gas will be increased due to this change in volume, then temperature of the temperature of the gas also increased, because of pressure is directly proportional to temperature. Pressure increased means temperature also increased, then pressure decreased means the temperature also decreased. Cylinder, then 1 mole of gas, then closed with a frictionless piston, then pulling this piston downward, then volume of the gas decreased, then automatically pressure of the gas will be increased. Because of these two parameters are inversely proportional to one another. Due to that increment of pressure, the temperature also increased, because of these two parameters are directly proportional. Now let's come to fundamental laws of gases. Fundamental laws which gives the relation between, underline, relation between the pressure, volume and temperature of the gas. First we will state that Boyle's law. When the temperature of a gas is kept constant, what is meant by that? The temperature of this gas will be constant. The volume of a big fixed mass of gas is inversely proportional to its pressure. That means volume of the gas is inversely proportional to pressure of the gas. That is, V is inversely proportional to P. In other words, we can write pressure is inversely proportional to volume. Now this expression in relation format, then we want to convert in equation format means I will introduce a constant here, that is this expression rewritten as pressure is equal to constant divided by V. In other words, volume is equal to constant divided by P. Now I will take, in first case I will take this volume into left side means we can able to get PV is equal to constant. In the second case I will bring this P into left side means PV is equal to a constant. State Boyle's law. When the temperature of a gas is kept constant, the volume of a fixed mass of gas is inversely proportional to its pressure. Already we have learned that in the two-dimensional demonstration. From the above expression, for an invariable mass of a perfect gas at a constant temperature is the product of its pressure and a volume of a gas. That means what? PV is equal to a constant. That is why I am written like pressure into volume is equal to a constant. Next one, Charles law. The another name of Charles law is the law of volume. When the pressure of the gas is kept constant, the volume of a gas is directly proportional to the temperature of the gas. We know that volume is directly proportional to temperature, that is V is directly proportional to temperature. Then volume increased means the temperature also increased. This is somewhat different in this case. Then volume is equal to constant into temperature. In other words, V is equal to constant into T, that is nothing but volume divided by temperature. That means the ratio of the volume and temperature is equal to a constant. Next we will learn about Avogadro law. At a constant pressure and temperature, in the case of Avogadro law, pressure and temperature of the gas kept constant, and the volume of a gas is directly proportional to the number of atoms or molecules present in it. Volume increased means the number of atoms or molecules of the gas will be increased. Here they are telling about the occupation of the magnitude of number of atoms or number of molecules only. That means volume is directly proportional to number of atoms or number of molecules. That is written like V is directly proportional to N. Here V means volume of the gas. This is one of the important parameter, and N is number of atoms or molecules present in that gas. Then I will introduce the relevant constant to this expression. Then V is equal to constant into N. Then this N comes to left, means V divided by N is equal to constant. And one more parameter I will define here, that is Avogadro number. Note down this. The total number of atoms per mole of the substance is equivalent to the Avogadro number. Number of atoms or molecules per 1 mole of the substance. That substance may be variety of gases, but Avogadro number means we want to take 1 mole of substance in a container, then to determine the number of molecules or atoms in that container means that is equivalent to 6.023 into 10 power 23 atoms. That only denoted as Avogadro number.